So we'll start with Cramer's rule. Cramer's rule is just another way of solving a system. So you can kind of see down there an example. I just have another system of equations, and I'm just solving it. Yeah. I haven't been anywhere but over here. And after we left, no one else has been in the classroom. You were the first one in. So what Cramer's rule does is we take a system of equations, and we're going to create, depending on how big your system is, depends on how many matrices you need. So the first matrix you make is an A matrix. A is going to be a matrix of coefficients. Now, describing the other matrices is where, I don't know, I have problems describing them. It's easier to show you than to describe them, but the next matrix will be an X matrix. What we do, nice head on. Is we take out the X coefficients and we replace them with what is on the other side of the equal sign. And then we would have a Y matrix, and we would do the same thing with the Y matrix. We would take out the Y coefficients, and we would replace those with whatever's on the other side of the equal sign. Yeah, now, the X and the Y matrix begin as the A matrix. I should put that in there too. It starts as the A matrix. You just take out the X coefficients, you replace them with whatever was there as the equal signs. Again, I have an easier time showing than explaining. And then depending on how many variables you have, you keep going. So if you have 3 sets of variables, then you would do the same thing. You would create a Z matrix. If you have 4 sets of variables, usually the 4th variable is W. So then you would have a W matrix. Okay. Then your actual X answer is the determinant. So these are actually matrices. I don't know why I was using the absolute value sign. Sorry. Is the determinant of X divided by the determinant of A. The Y matrix is the determinant of Y, the Y answer is the determinant of Y divided by the determinant of A. And then if you had a Z, it would be determinant of Z divided by the determinant of A. If you had W, it would be determinant of W divided by determinant of A. So that's Cramer's rule. Now, Cramer's rule can take a long time if you're having to do determinants by hand because large determinants take a while. So I'm only going to request that you do 2 by 2 determinants because those are quicker. Whenever we get to the calculator, then we'll do the larger ones. Okay, so if I did this, My A matrix, why do I keep putting the absolute value sign? Would be the coefficients. So 3, 7, -4, 5. Okay, my X matrix what I'm going to do is I'm going to take out the X coefficients, so the 3 and the -4. I'm going to replace it with whatever's on the other side of the equal sign. So I take out the X's and replace it with the equal sign numbers. Go ahead.
Where did those X's come from? You got X equals.
Okay, I take the A matrix.
Yeah.
Okay, the X coefficients, I take them away. So the 3, -4, I take them out, and I replace them with the numbers from over here.
Okay.
So I take out the 3 and the -4, and I replace it with the -2 and the 6 from on the other side of the equal sign. So the Y matrix is the same thing. I take the A matrix, but instead of using the Y numbers, I replace the Y numbers with the equal sign numbers. Okay, I'm going to go ahead and calculate the determinant of each of these. So determinant of A, since it's been a little bit, let me go ahead and go back through that. Determinant is when you cross multiply, so it'd be 3 times 5 minus 7 times -4. With determinant, you always subtract. Nope.
Well, it will be added.
It switches signs each time. So if I had a third set, then I would add. So it'd be plus, minus, plus, minus, plus, minus. But with a 2 by 2, you always subtract. You always start with addition. So plus, minus, plus.
So however many rows you have, columns you have.
Okay, so this is going to be 15 plus 28. So 43. Determinant of X is going to be -2. Oops. It helps if I actually put a 2 in there. Times 5 minus 7 times 6. Yeah. Sorry, that's a 2 in there. I wrote a parenthesis before I put the 2 in. So that's -10 minus 42. So it's -52. Determinant of Y equals 3 times 6 minus -4 times -2. So that's 18 minus 8. So my answers are going to be X is determinant of X divided by determinant of A. So X is going to be -52 over 43. No, that's just the determinant of the X matrix. The actual solution is that number divided by the determinant of A.
Oh, so that's like the X value.
Yep. So remember, whenever we solve this, we're actually looking for an ordered pair. So y is determinant of y divided by determinant of a, so that's going to be 10 over 43. So if we were solving this by substitution or elimination, those would be the values that we got. So you know the actual answer, if we were being strict and cranky about it, would be negative 52 over 43, 10 over 43. I just want x and y. You don't have to put in order pair. We didn't put them in order pairs when we were doing the inverse method. Yeah, for determinant, that's when you do your cross multiplying.
So that's why you have negative 2 times 5?
Yep. Okay. Any question about Kramer's rule? You good with it? We're going to do area of a triangle, but that's it for Kramer's rule. Okay, if you have a triangle and you can put it on a coordinate grid and get coordinates for it, you can use a matrix to find the area of a triangle. Area of a triangle is equal to plus or minus. The reason why we use plus or minus is because the formula we use can give us a negative answer. If we get a negative answer, we just make it positive. Oh my God.
It's majestic, don't kill it. Wait.
Whoa.
You're gonna die.
Yes, I'm going to die now.
Don't kill it.
It's just a sentence.
Are you interested? What? Kill it.
Fire. It's cute. Go ahead and say that. It's still moving.
Ah!
On accident.
Yes.
And we're gonna die without
No, it's not.
It won't die without it, right?
Or it's one of its legs. Still has both of its legs.
Okay, cool. So it's still alive. How are you
Oh, yeah,
gonna
it's still
get by
alive.
this?
You want it?
No, I don't want it.
Just dump it in the trash. It's long.
Kill it!
There's a call back now.
Take a picture.
Tear it up.
Yeah, they could do that.
So you throw it on the wall.
If he leaves it, it can have babies, okay? And there's gonna be thousands of them.
It eats roaches.
Yeah, then you all want a few of them for a pet.
Do you want to have the centipede or do you want to have roaches?
Neither.
Centipede.
Centipede.
I'd rather have
Huh?
tarantulas.
Behind the cabinets. I'm sorry, did you want a picture?
No, we're its friends. We're its friends, probably.
Little did he know, like 20 years from now, he's gonna look back, and that's gonna be like the ancestor of the horde of centipedes that invaded.
Oh, there's already tons of them.
I'm just gonna look behind the cabinet one day and the centipede's gonna be like this long. It's gonna be like, it's gonna look good.
I wish these things.
You're sounding good. Freak out. Freak out about bugs. Hey, hey.
Okay, now I'm going to show you a way to cheat at this to make this a lot easier. But this is your formula. So again, the reason for the plus or minus before the centipede attacked, determinants can give us negative numbers. Can your area of your triangle be negative?
Yes.
No. So With the plus or minus, you just use that to make your answer positive. So that's the only point of the plus or minus. You just choose the one that makes your answer positive. It's not some magical thing out there that you have to use all the time. Just make your answer positive. Yes, and then you always use 1/2. Basically, the matrix takes the place of your base times height. Why the hell are you taking pictures of me? Creeper?
It's filmed, so I won't know.
So basically, this takes the place of your base times height. So this is your 1/2. All right, so this is a triangle. Any 3 ordered pairs, as long as they're not collinear, make a triangle.
Define collinear.
Make a straight line. So here's, 2, 8 is somewhere up here. 3, -1 is like right here. -2, -3 is like right here. So that'll make a triangle. Okay, so I'm going to start you off. I'll show you this.
Wait, so those are random coordinates?
Yeah, I just made them up.
Cool.
Okay. So you calculate that determinant, and that gives you the area of the triangle. Now, the only problem with that is, who wants to calculate a 3x3 determinant? No one. So let me show you a shortcut. In geometry, did you guys do things like rotations and translations and that kind of stuff? Okay. If I do a translation, does it change the size of my figure?
No.
Okay. For those of you who don't remember what translations are, translation is this.
Just move it. It's a slide.
I translated Sam. Sam did not get bigger or smaller. Sam just moved. Sam just translated himself back.
The inside of your back.
Okay, so what I'm going to do is I'm going to translate that triangle to give myself better numbers. What would be the best numbers I could have? 0, 0. So instead of having 2, 8, it would be great if I could have 0, 0. So what do I need to do to turn that 2 into a 0? Subtract 2. So subtract 2 from all your x values. Yep. Okay. To turn the 8 into a 0, what do you have to do? Subtract 8. So I subtract 8 from all my y values. Now, that is the exact same triangle. It has just been translated. So now that this point here is right here. This point is now down here, and this point is now over here.
So, don't translate the language that's false.
Yeah, go ahead.
Does it have to start with that first?
You can pick whichever order pair, because I randomly made up those order pairs, right? So I made up the order that they were in.
Does it matter which
Nope. I could have made them up in an entirely different order. It would still be this exact same triangle with the exact same area.
So, how did you translate it? What did you do?
Whenever you translate, you literally just subtract the numbers or add numbers to them to move them to wherever you want them to be.
Where did, how, what was,
So I chose this order pair to move this order pair to 0, 0.
okay.
So to move 2 to 0, I subtract 2. So I subtract 2 from all the x's.
Okay.
To move 8 to 0, I subtract 8. So I subtract 8 from all the y's. If I would have wanted to move this one to 0, 0, I would have subtracted 3 and added 1.
Oh, so you have to put one of them at 0?
Let me show you why we want to do that. Because now, this is my matrix that I have to find the determinant of. Because it's the area of a triangle. What's the area formula for a triangle? Oops. So now wherever I go to find the determinant of that, your determinant formula says I take the first number times the determinant of this. I don't care what the determinant of that is because 0 times anything is 0. Minus the second number times the determinant of this stuff. I don't care what that is because 0 times anything is. Plus the third number times the determinant of this stuff over here. Well, I do care what that is because I actually have to do that one.
Yeah, the numbers aren't related to that. Oh, wait, yeah.
Okay, I'm taking the determinant of 3 by 3. You guys are supposed to already know that one.
I don't know how to do that.
So you did the 0 first. The 0, you multiply by 0.
Remember, there was 2 ways to do determinant over 3 by 3.
Oh, I got you.
We take 0, we cover up these two things, take it times the determinant of what's left. Then we move over to the next one. Or you could have taken these two columns and copied them outside. You can do it whichever way you want to.
Why is that a negative 0?
Because we do plus, minus, plus.
Can you show us the way we put the numbers on the outside?
Doing the numbers on the outside, you would have plus or minus 1/2 times the determinant of 0, 0, 1, 0, 0, 1, negative 9, 1, 1, negative 9, negative 4, negative 11, 1, negative 4, negative 11. But again, wherever you start doing your multiplications, what is this multiplication going to be? What is this multiplication going to be? Oh, I actually have to do that one. Whenever I go backwards, what is this multiplication going to be? What is this multiplication going to be? I lost my other one. This one. Not 0. Subtract them. I still like this way better. I don't care.
It's too confusing.
Why are there so many numbers?
This one's just times negative 11 minus 36.
Do I have to know these numbers and what I'm saying?
So that's 47 halves. It would be negative 47 divided by 2. And then make it positive.
Why is it on the...
Where's the unit squared?
Huh?
The unit squared.
Yeah, units squared. I don't care. I am more interested in you actually knowing how to do it than you putting units on it. I honestly, if you got all the way through this, I would be a jerk for taking off units because
They do that.
I know. Okay, you good with that?
Yeah.
If you forget to translate, you can still do it this way. It just takes a little bit more work.
Oh, wait, because it's a half. Wait, so the plus or minus just kind of disappears?
The point of the plus or minus is your area has to be positive. So like on this one, I would have got negative 47. I cannot have a negative 47 for an area.
So it turned into.
So I use the plus or minus to make it positive.
Okay, cool.
That's the only point to it.
Cover up what's under there. So, say you're using something like this number here, cover up. You're never gonna.
Huh? Yeah. Okay, let me verify that homework real quick because I was in a rush whenever I did that. Oh yeah, let's change that. Instead of 1 through 9, let's do 1 through 5.
I mean, or you could do the other way. I don't
Yeah, that should be good.
Is that 1 through 5 already?
Yeah, do 1 through 5 instead of 1 through 9.